In this module, we'll be adding Firebase Realtime Database, a little slice of internet, to our already working Quick Start button LED electronics. So the Firebase Realtime Database is my favorite way to do IoT prototyping. And that's because it's really easy to implement. It plays really well with JavaScript and Johnny 5. And it's definitely my foundation for any circuitry, electronic-y, IoT stuff I do. It doesn't mean it's perfect for everything. If you're doing for example, if you're doing something that requires extremely low latency, this isn't going to work very well. You're going to need some kind of point-to-point connection. That's because the real-time database synchronizes all of its state, like its source of truth is a database in a data center somewhere. So you're limited by things like the internet and the speed of light for how fast it can refresh, about 100 millisecond response time. Another thing it's not perfect for is really high throughput systems. If you have like a sensor network that's doing like 5 or 10,000 QPS, it's not going to be cost effective. You probably want to use something like IoT Core or PubSub solution or something like that. You don't need to synchronize all of that state all the time. So for this module, I'm assuming you've already completed the quick start. If you haven't, go back and do that. I'm assuming you have a button and an LED that work when they're on. I'm assuming you have the program from the end of that section. And that's actually all I'm assuming. So let's go ahead and get started. The first thing we're going to need to do is install Firebase tools. So I already have it installed, which I can verify by typing which Firebase and seeing that I have the command line interface. There's actually a couple packages out there. Firebase tools is the right one. You don't want Firebase CLI. That's like an older version from Firebase version 1. It's pretty old. You want Firebase tools, which is supporting the latest version of Firebase. You need to install it. You install it with a command like this, npm install-g firebase tools. And using the G flag for a global install because you want to install the command line programs. So I'm going to go ahead and let it double install itself. And while that's happening, we're going to go ahead and create a Firebase real-time database to use for our project. We go to console.firebase.google.com, log into a Google account, and then create a project. You're going to click on Add Project, and you're going to type in the name of the project you want to use. I'm going to use NodeBots Yay, and I'd click Create Project. I've already done that because I already created that project earlier, but it's going to lead you to the same place. When you click, you're going to end up on the console with your created project. Firebase is a whole bunch of different goodies for mobile and web application development. We're only using one tiny slice, the real-time database, the original feature of Firebase. And I have stuff in there. But when you get there, on yours, it'll be empty. It'll look something like this. It'll tell you its URL, which is probably the name you typed in. It might have some other stuff to disambiguate it from other Firebase databases. And it'll be empty right now. But when you're using it, it'll be full of essentially a big old ball of JSON. And your clients, your IoT clients or your mobile web applications will interact with that JSON using the client libraries. So we have the tools installed now. So the next thing we want to do is we want to add a dependency. We want to set up our client library. And there's a couple different client libraries you can use. We can find in the docs. You can use a couple different JavaScript libraries exist. One is generally intended for web applications, and it has a different authentication path. It's assuming another user is using it. But with the IoT thing, we're assuming that you, the owner of the Firebase, are using it. So you want to use the admin SDK. And this has a node.js library that assumes kind of a privileged state for your real-time database. Basically, it circumvents the normal security rules because it's you. It trusts you. And it's a great place to start with doing NodeBot type stuff. So let's go ahead. We've already installed it. Oh, we haven't installed it. So we want to install it in our project. We're going to do npm install firebase-admin and --save, so it writes it to the package.json. Then we're going to want to go to our code where we left off previously. We're going to want to add our dependency. We want to add the requirement. Anyway, we want to require our admin SDK. And then we need to initialize our SDK. So for that, we're going to need to create a service account. So I'm going to scroll back up and I'm going to create a service account. This link in the docs will take us right to the right place in the Firebase console. We're going to do this with NodeBots, yay. And we're going to generate a new private key. This private key is how Firebase's real-time database and the other parts of Firebase know to trust our little IoT device. We're going to generate a key and it'll give us a JSON file which contains secrets, basically private keys. Don't show this to other people. So I'm going to go ahead and copy it into where I'm working. I'm going to rename it to service account.json. Copy it into the working directory for my source code right next to index. And we'll be using this to authenticate. Hit the back button a few times and go back to the documentation. Not that far back. Scroll on down, and now we can go to the step where we initialize the SDK and authenticate as an administrative user. So we do have the source code open. We're going to go back to the source code, and we're going to do this work right when our script starts up, even before the board is ready. So we already have the admin SDK required. Then we're going to get a handle on our service account, which is just that JSON file. Service account.json. Then we want to initialize our application and point it to our database. So this one is NodeBots, yay. Oops, mistyped. There we go. We close that string. This would be, of course, the path, whatever path you have for your actual application. You're not going to use NodeBots yet, because that's my Firebase database. So with our database initialized, we can keep on scrolling down. And we're actually going to kind of skip ahead. There's a bunch of other stuff that teaches you best practices and stuff like that. We are going to go and read and write data from the Firebase database. And we're going to skip ahead even further to saving data. So the first thing we're going to do is when we press the button on our device, boop, boop, we want to write information to the real-time database. And we're going to use the set method to do that. There's many different ways to write. We're going to use the very simplest one, which is where we give it a path and we give it JSON, and it just makes that path in our database equal to that JSON, stopping whatever happens to be. So we're going to need to get a reference to a location in Firebase in our real-time database. So we're going to take the admin SDK. We're going to tell that we want to use the database feature of Firebase. Then we're going to get a path. And this can be anything you want. I'm just going to do button. You could even make it the root of Firebase if you want. And I'm going to call this button ref, the reference to the button location in Firebase, in the Firebase real-time database. The next what we want to do is we want to call the set method, which gets described right down here. So given a reference, you call the set method on it, and then you can pass in anything you can represent with JSON, Booleans, numbers, JavaScript objects. I'm just going to pass in a string. Button ref dot set down. And when it goes up, I'm going to update it again. Button ref dot set up. And it's really that simple. Well, let's see if it's that simple. Let's see if it actually works. I'm going to bring up the real-time data, the database viewer, and I'm going to fire up our program, connect it to the board, and it initialized. When I press the button down, it worked. The down state from here got set, pushed up to the Firebase real-time database, and it updates on the internet. But this is only half of the story, because what doesn't happen is if I change this to down in Firebase, the internet change is not reflected on my device. The LED doesn't turn on and off. That's because our device can only write so far. We want to complete that circle and skip ahead to the retrieving data section of the docs. And scroll on down. Let me pull this in so it's not quite as blocked by the projector. And the way you do that is there's a bunch of different ways to listen to locations of Firebase. You can create queries against paths. You can do all sorts of stuff. We're going to do the simplest way to read. We're going to have a value listener. And what a value listener does is it calls a couple of different functions when things happen on a path in Firebase. So let's go ahead, copy this code, and go below our button code and paste it in. So there's two functions that get passed to this value listener. The first one gets called when anything changes on that path. So it gets called once to catch us up to the current state when we start our program. And then whenever something changes on the internet in the real-time database, this function will get called again with a snapshot of that data, which includes the value itself as well as some metadata. If things go wrong at any time, disconnection, client misbehavior, whatever, something weird, security violation, stuff like that. Like for example, if you set up security rules that prevent you from reading that location, then this error function will get called. We can leave the error method the way it is. What we're going to do here is we're going to modify this a little bit. We're going to just extract that value out. And then we're just going to do a little if statement here. If the val is down, we will turn the LED on. If it is up, we'll turn the LED off. So we'll go ahead and we'll copy this stuff out. So we're kind of assuming here that if it's not down, it's up, which helps if we accidentally type yucky stuff into the database. And here's the really cool thing is that Firebase, the client library, does a lot of the heavy lifting. So you might have to think about like, how do you keep this local state and this remote state synchronized? And you don't really have to. Just write to the Firebase client and it'll take care of calling any of the local methods right away. It won't wait for it to synchronize to the internet. So we can just go ahead and delete these and run our software again. Bring up our database viewer one more time, and I made a mistake. Oh yeah, the ref has a name. It's button ref. So I want to do a listener on button ref. This time it initialized correctly. So here's our database viewer again, and we press our button down. The LED turns on and off just like it did before. Except now there's another cool feature is that when we change the internet, our electronics will change to match. The LED will turn on when we type down here. If we type anything else, it'll turn off. So if we had two of these devices, both connected to the same real-time database, we could have a really, really overcomplicated telegraph. So we've written data and read it, or we've read the data and put it into an LED. So that's it for this section. So I hope it was useful. Go ahead and grab that next module and keep on hacking.